our y-axis, so we're going to look at this axis here. If I look, there's a point right here halfway between 30,000 and 25,000 or 20,000. So halfway in between there must mean that this is 0 because we didn't go over any x, comma, 25,000. Okay, so the point that lies on the y-axis, we can fill in over here, is 0, comma, 25,000. All right, so then what is our y-intercept or our b? Well, that's pretty easy. It's right here because this is our x and this is our y. So our b is 25,000. Okay, she automatically starts with a salary of 25,000. If she doesn't sell any policies, then she doesn't get an increase, but she starts off at this. Okay, now we have our b. Okay, we need to find our slope. So we have to remember one other equation, and that's the slope formula. And I would suggest writing this on the top of your paper as well. M equals y sub 2 minus y1 over x sub 2 minus x1. All right. So that means we need to have 2 points because I need a change in my y over my change in x. Okay. So where's another point? Correct. There's this point right here that they gave to us. Oh, imagine that. They made our lives easy. All right, so let's take a look. So I'm going to label this with an x and a y so don't get confused. And I'm going to make this my 2's just because it's easier to subtract when the first number is bigger. Then I don't have to deal with the negatives. So I'm going to start over here with 30,000 minus 25,000 over 5, my x values, minus my other x values. Well, it's easy to do the bottom. 5 minus 0 is 0. And then I end up with 5,000 on top. Oh, my mistake. 5 minus 0 is 5. Silly Miss B. So this is over 5. When I divide it, it's pretty easy. It is just 1,000. So if we go back here, our M is 1,000. So now all we have to do is plug it into our formula. We said M was 1,000 and this was 25,000. So the function rule is for every sale she makes, she's going to multiply it by $1,000 and add it to her base salary of $25,000. So the base salary, again, is $25,000 and the rate of change is 1,000, which is the commission for each policy the salesperson sells. Not too complicated, hopefully. It's just using these 2 equations to interpret the information in either a words, table, or in this case, graph. Okay? All right. Now what I want you to do is I want you to pause the video and I want you to do all the quick check problems. Then, when you've done them all, you can replay the video, unpause, and you can check your problems. So go ahead and pause. Okay, let's go over the quick check problems, and Miss B is going to pull this out carefully. All right, the first one reads, an orchestra buys music stands for $42 each with $298 in its bank account. Write a function rule that shows the account balance depends on the number of stands bought. What is the initial value and the rate of change of the function? Woo-wee! All right. So first, we have to figure out what is our rate of change and what is our initial value. All right. So as we have two values given to us. We first have the $42 each for the music stands, and then we have this amount in our bank account. Ding, ding, ding. To me, automatically hearing this is how much I have in the bank should say, okay, this is my starting or my initial value, which we know is B. So I'm going to go ahead, write M equals, then I'm going to write B equals, and I can say right now that it's going to be $298. Okay. Now, it costs $42 for each music stand. So when I look at this, I'm going to go, okay, each. This is another keyword. It's like per, so if it's like per, then it must be like slope. All right, so my slope is going to be $42, or my rate of change. Now, how do I write a function? Now, this is where it gets tricky and we have to think. So, the amount of money, our output, Y, is going to equal, well, our starting value is $298, so $298 minus 42 times the number of music stands. I wrote it in this order, even though we're used to seeing it as Y equals MX plus B, we can also see it as Y equals B minus MX. Okay? I wrote it in this form because our initial value is something we're subtracting from, not adding on to. Because in this case, with each music stand I buy, I'm going to subtract $42 from this amount. So my bank account is going to go down, down, down. Miss B knows a little bit about this as she likes to shop. All right. 2. The table one. So this was our words practice. This is going to be obviously our table practice. Oh, sorry about that. All right, let's make sure we're lined up. Okay. So the table shows the inches of snow during a snowstorm. Write a function rule. What is the initial value and the rate of change? Again, initial value is our B and the rate of change is our M. All right, first of all, we have to look and see what is each thing going up by each time. All right, if I look here, 3 to 6 is plus 3 hours because X is the number of hours. 6 to 9 plus another 3 hours. 9 to 12 plus another 3 hours. Okay, here, 4.5 to 9. Inches of snow, well, 4.5. Okay, now we go this way, 4.5. And then if I added 4.5 to this, it would equal 18. So they both check. This is going up by the same, and this is going up by the same. Now here's where it gets a little tricky. If no hours have gone by, has snow been able to accumulate? No. If the snowstorm hasn't started yet, the time hasn't started, the snow's not going to start. So in this case, we're not going to have an initial value. Our initial value is just 0. So we need to find the slope though. So M equals our change in y over our change in x. I'm going to come over here. Our change in y was 4.5 over our change in x, which was 3. If I divide 4.5 by 3, and I'll quick double check on my calculator, we get 1.5. So this is our m. Okay, so when I write my equation, I'm going to say y equals 1.5 per hour. And if you notice here, we didn't start at hour 1, or we started at hour 3, but if we had gone back 3 hours at 0, we would have to subtract 4.5, and that would be 0. So if I wanted to know what was it though as it increased 1 hour, again, we have to find the change. That's our m. So this is our equation. All right, last one. 3. The graph shows the height of a snowman over time. Write a function rule. What is, again, the initial height, initial value? So that's our b, and the rate of change, our m. All right, so let's take a look. If I'm over here, I'm going to try and find 2 points. Oh, look, here's one right here, 7, 5, 5, all right. And then here, oh, how handy is that? We have a point that falls exactly on our y-axis, which means, yes, I have found the initial value already without having to do work. I just highlighted. So our b equals, well, each one of these lines counts, so 5, 6, 7, 8, 9. Our initial value is 9 feet, okay? Wow, that's a big snowman. Started off as 9 feet. Well, as you know, as it gets sunnier during the day, snow tends to melt, so the height of our snowman is melting. So what is our rate of change? What am I going to do? Oh, that's right. This is at 9, and when it doesn't go over at any x values, I know that this point is going to be 0, 9. Look, now I have 2 points, x, y, x, y. So I'm going to solve for slope. So I'm going to come here and write m equals y1, 9, minus y2, 5.5 over 0 minus 7. And I end up with negative 7 over 3.5. All right. Okay. So when I look at this, half of 7 is 3.5, so this is actually negative 1/2. Okay, can divide by 3.5 on the top and the bottom, and I get negative 1/2. So this is our slope because I use the slope formula. All right, can't remember the slope formula? It is right here. It should be at the top of your paper. y2 minus y1 over x2 minus x1. All right, so now I have my m and my b. So all I have to do is put it in an equation. Now, again, I can write it in either way. Okay, it'll still give me the same answer. All right, but I'm going to put in y equals mx plus b form. So y. Then what is our slope? Well, we said negative 1/2 x, all right, because that little x is there, plus b. B, don't forget, was our 9 feet, so plus 9. There are the answers to your quick check problems. I hope this was helpful, and I hope you understand the lesson. If you have any questions, come see me. I'll be willing to help. Goodbye.